is equals to plus or minus ln of 1.2 plus square root of 1.2 squared minus 1. By expressing cos inverse of x in logarithmic form, determine the value of cos inverse of 1.2. So we want to express cos inverse of x in logarithmic form. That's the first thing, isn't it? So how do we express cos inverse of x in logarithmic form? So you say, let y to be the cos inverse of x. So by the time we found y, it means we found the cos inverse of x, isn't it? You see that? So if y is cos inverse of x, then it implies when you bring cos inverse of this side of the equation, you get cos y is equals to x, isn't it? You get cos y is equals to x. Then you ask yourself, so cos y is equals to x. Then you go to the exponential definition of cos and sin. So if you have exponential y is cos y plus sin y, isn't it? Exponential y is cos y plus sin y. So from here, we apply the Numerical logarithm, isn't it? Because we are looking for y, in that y is the cos inverse of x, what we are looking for, isn't it? So for us to get y, we introduce the Numerical logarithm on both sides of the equation, ln on both sides of the equation, isn't it? So if you introduce ln, y becomes the coefficient, isn't it? Y becomes the coefficient. So we have y ln of e. So ln of e is 1, isn't it? So this side of the equation, you remain with y. But what is y? Y is what we are looking for, which is the cos inverse of x. So y is the cos inverse of x. So we found cos inverse of x. But you see, on the left hand side, it is now in logarithmic form. But we need what? We need everything in terms of x, isn't it? So it means we have to get rid of cos y and we have to get rid of sin, isn't it? So you go back to which identity relate cos and sin. Are we together? So the identity which relate cos and then you start with the trigonometric identity. So in trigonometric Pythagorean identity, if you have cos squared y plus sin squared y, that is equals to 1. Pythagorean, isn't it? Cosmos rules say when you have a direct product of two sine functions, the sign changes only if there is a direct product of two sine functions. Only sine function. There's a direct product of two sin functions here, sin squared y. So in hyperbolic, the sign is going to change to negative. So it is going to be cos squared y minus sin squared y is equals to 1. So this is the Pythagorean hyperbolic identity. Cos squared y minus sin squared y is equals to 1. Cos squared y minus sin squared y is equals to 1. Now, having noted that hyperbolic Pythagorean identity, then we now want to use it to get, we have cos y. So we want to use it to get sin y. So what is sin y? So you've been given cos y, you already know cos y is x. You can substitute that, isn't it? We are now looking for sin y. So for us to get sin y, we make sin y the subject of the formula, isn't it? So making sin y the subject of the formula, negative sin y going on the other side of the equation, it becomes 1 coming on this side, it becomes. So it means cos squared y minus 1 is equals to sin squared, isn't it? But cos y is x. So if it is cos squared y, it means it is x squared, isn't it? So x squared minus 1 is sin squared y, isn't it? Are you together? So from there you find the square root on both sides to get sin y, isn't it? So what is sin y? Sin y is plus or minus square root of x squared minus 1, isn't it? So can we now go back and substitute that in our logarithmic form of the cos inverse of x? So the logarithmic form of the cos inverse of x is now ln of cos y, which you found to be x, isn't it? Then plus or minus square root of x squared minus 1. So this one, if you remove plus or minus inside, use the principal value there, you have. So cos inverse of x is plus or minus ln of, in bracket, x plus square root of x squared minus 1. Now we've now found the logarithmic form of a cos inverse of x. Having determined the logarithmic form of a cos inverse of x, we now use it to determine the value of cos inverse of 1.2 is equals to plus or minus ln of 1.2 plus square root of 1.2 squared minus 1. You get 0.622 and that is the same value you got when you found the cos inverse of 1.2 direct, isn't it? You see that? So it is plus or minus that, but you can decide to work with one value, maybe the positive one, isn't it? Are you seeing that? The positive case, so that you have ln of that, and you get that, isn't it? Are you together?